Okay, go ahead and fill in the objective for the day. So fill in your objective. The more we talk, the longer this takes, the less time you have to do your practice, meaning you take home homework. And the goal is for you not to take home a ton of homework. What we're going to do is we went through a quick activity that went over inequality notation. So when I go through the left column of this, I'm going to go through it pretty quickly because we should hopefully remember inequality notation from Algebra 1. Now, we were really good about understanding that a closed circle means that it's included and it's going to be less than or equal to or greater than or equal to. An open circle is going to be not included, meaning that inequality is not going to have the line underneath it. And a lot of that is going to factor into what we do with set notation and interval notation. Set notation is really, really nice because it really is just a fancy way of doing inequalities. So first things first, let's start with A. We'll kind of make our way down, and then we'll actually get to what's important, which is writing this for domain and range. So in this case, for my first number line, I drew a picture, and it looks like it's starting off at what number? 2. The first filled in circle is going to be 2. So is that filled in circle going to have the equal to sign? Yes. So I'm going to do 2 less than or equal to. Because this one's called A, I'm just going to use variable A. What's the highest number this could be? 6. And so 6, since 6 is an open circle, it's just going to be less than 6. Yes, ma'am. Now, the new part, the part that you have not learned other than today. For set notation, we write set notation the same exact way for every single variable. The letter is just going to change. So the first thing you're going to draw is a curly bracket. And I know it's going to seem crazy, but we're going to draw a curly bracket. It kind of looks like this. You've probably seen it on your keyboard. Curly bracket. And this is variable A such that A is an element of all real numbers. Now, a little disclaimer here. When you get to pre-calculus, which isn't for like 2 years, you're going to do geometry next, and then you're going to do pre-cal. When you get to pre-calculus, this is the notation that they are going to use the most. For us in Algebra 2, and I think eventually geometry does it as well, we focus more on interval notation. So if you're like, when I see set notation, I don't want to do that, it's okay. You don't have to do it every single time. We may ask you to write it once on your test, but it doesn't have to be the one you use the most. You'll kind of see interval, it'll be a little bit nicer. The nice thing about this is once you write this notation, all you're doing, put a comma, is listing your inequality and then closing your curly bracket. This first part, this little fancy A such that A is an element of all real numbers, that's just saying that I can pick any number from negative infinity to positive infinity. In like all the way back in like 8th grade, you talked about sets of numbers. So we have rational numbers, we have irrational numbers, we have whole numbers, we have counting numbers. Real numbers just means anything is fair game. Anything from negative infinity to positive infinity. But all of our notations start off this way. Now, for the interval notation, a lot of people favor this one because it's a lot easier. With interval notation, and on the very bottom of your page, you can kind of see what looks like a little snowman almost. In the case of including values, you're always going to use brackets. In the case of excluding values, so an open circle, you're always going to use parentheses. So what's going to happen is the interval notation kind of just acts like describing the line. So by that, I mean, if I come back up here, I'm just going to draw this picture really fast up here. Boop. So we know this is going from 2 to 6, correct? Starting at 2, ending at 6. For the filled in circles, they're always going to have a bracket. So I'm just going to put a bracket around the 2. For the open circles, they're always going to have a parentheses. So I'm going to put a parentheses around the 6. And the only thing that goes in the middle is a comma. And that's interval notation. So interval notation literally is look at the number line and state the values that it's starting with and that it's ending with. So it's similar to inequality because you have 2 and 6, but it just makes it a little bit nicer. Now, I know this is the first time we're probably seeing this. It's a little overwhelming. We'll kind of cover all our bases over the next couple weeks. For the second one, do I have any restrictions? Or is that line going on forever? Forever and ever, right? In math, our forever and ever is from negative infinity to positive infinity. So it's going all the way down to like negative 1,000,000 and 5,000 and 600 and all of that, all the way to positive. In the case of inequality notation, a lot of the times, and your teacher may have done this, you may have not, but in Algebra 2, we typically just say, if I have no restrictions, it's all real numbers. So any number from negative infinity to positive infinity works. So when I write this in set notation, B, such that B is an element of all real numbers, close. Because there's no restrictions. After you write the starting part of set notation is when you include any restriction values. We don't have any in this case. So if you have all real numbers as a part of your answer, it's going to just be an element of all real numbers. Now, thinking about what this number line looks like. It goes all the way out left, right. So it's going from negative infinity to positive infinity. And what I like to usually say is this comma is kind of like you saying the word to. So negative infinity to positive infinity. 2 to 6. Kind of like your spacer. Now, the one thing, is there a number that represents infinity? No, because it goes on and on and on and on forever and ever and ever. So since there's no ending number, anytime you have an infinity, it's always going to be paired with parentheses because there's no value for me to include. It's going to go on. It can keep growing and growing and growing. So if you ever are writing interval notation and you have an infinity as a part of your answer, it will, no matter what, always be a parentheses. Okay, now jumping to the next one. It almost looks like B, but what's the difference?
It's not 3.
There's not a 3. So when I do that, it's kind of like saying C can be anything, but C cannot be what number? 3. And we say that by saying C cannot equal 3. So when I write, and again, I'm telling you, it's going to be literally the same thing every single time. C is an element of all real numbers. We'll just say C cannot equal 3. And like I said before, you will get preference for what you want to do on your domain and ranges. After today, you'll mostly see me write domain and range in interval notation. But if you're someone who's like, I know how to do inequalities, I know how to do set because I know how to do inequalities, we will still accept those as answers because they are valid answers. It's math. You're doing the right math. It's just you kind of get to pick which one you like better. Okay, now this one's a little bit tricky because when I think of this line here, I have one value that I cannot include. So what we're going to do is it's kind of like we're almost going to write the left side separately from the right side. So if I write the left side, that's going to go from negative infinity, because my arrow is still pointing down. It's including all of those values, all the way up to 3. And then on the other side, it's going from 3 all the way up to positive infinity. Now, in interval notation, there's one little thing that we have to include in between the two sides, and that's what we call a union. So at the very bottom of your page, you'll see it looks like a little U. It is a U. You can draw it like your regular U's if you prefer. But that union is what's going to go in between your two sides. Because technically this is one number line, it's just not including that singular value. So anytime you want to skip over a part, it doesn't necessarily have to be just one number, it can be a gap. Anytime you're doing that in interval notation, you're always going to include a U. And we'll talk about that once we get down to E. Okay, for letter D, it looks like I'm starting with 1 and I'm going all the way up to positive infinity. So when I write that in inequality notation, that means my D is greater than or equal to 1. Because the smallest number that I can include is going to be 1. So when I write the set notation, D such that D is an element of all real numbers, D is greater than or equal to 1. It also can be 1 is less than or equal to D. Same thing. Again, the direction you write this in isn't going to necessarily matter as long as the inequality is facing the correct value. So if it was facing the 1, that's when it would be incorrect. But since it's facing the D, because remember it's like an alligator, it wants to eat the bigger number, you would get it correct. Okay, looking at what I have, kind of looks like this. So remember, when you write interval notation, it's like you're writing what you're seeing on the number line. So 1 is my starting value. I'm going all the way up to infinity, and in between we put a comma because it's kind of like we're saying the word 2. So 1 to infinity. And whenever you have a filled in circle, you're always going to have a bracket. And whenever you have an infinity symbol, you're always going to have a parentheses. So open circles, parentheses, infinities, parentheses, closed circles, brackets. You will only ever use brackets for closed circles. Okay. Interesting part here, we've got two things. We have two inequalities. If you ever find that you have a gap in the middle, we think about them separately. So in this case, I have number line E. E is going to be less than what number? 4. So E is less than 4. And then we have E is going to be, and I'll kind of write it in the order it's supposed to be in. E is greater than or equal to 7. I find that there are my people who visual learners, if they put the numbers directly underneath the number line, it makes it a little bit easier for them. But in this case, that's what I did. But it also would have worked if you would have said E is greater than or equal to 7. Same thing. Just make sure you're paying attention to what you're actually saying. So this is all the numbers bigger than 7 is what I want to include. In the case of a gap this large, we always put the word or in the middle. So it's one or the other. In the cases where they kind of come together and you have like two ends and everything in the middle is shaded, that's what we consider to be an and. So it's usually an and statement or an or statement. If they go in separate directions, that's an or statement. So I'm going to come in E such that E is an element of all real numbers. And then all I'm going to do, like I've done before, is write what I have for my inequality. And here's where I usually have a lot of my former students say they made the decision that they like interval notation better because they're writing a lot less with it. So right now, if I were to kind of write this in interval notation, I have an open circle, I have a closed circle, and this is 7. So remember, interval notation is literally just taking the values that we're looking at. So if it's an arrow to the left, that's negative infinity. I have a 4, I have a 7, I have an arrow to the right, which is positive infinity. And then going in and filling in the missing parts. Parentheses always go around the infinities, no matter what. Open circles have parentheses, closed circles have brackets. And then you always have a comma to kind of say 2 in between. Anytime there is a gap in your data, that is when we go in and we use the union. So in the middle, we're going to put a U. And a lot of my former students that I've talked to about, like, which one did you like better, set or interval? They say that they like interval notation because they don't have to remember everything from set notation. Eventually in pre-calculus and calculus for sure, if you make it all the way up to there for your senior year, you will have to do some form of set notation, but it's not a requirement here in Algebra 2. Okay, last one, discrete data. So we call this discrete. You may have heard this before in Algebra 1. You probably did, and you may not remember. But there's 2 types of data. There's discrete data. There is continuous data. Continuous data is everything we've kind of been looking at so far. If you have a line connecting multiple numbers together, that is continuous. That means it can be any decimal in between those numbers. So in the case of having discrete data, since there is no connection point for these values, there is not going to be any interval notation. So no interval notation. So if you ever look at a graph and it's just a bunch of like points, like a scatter plot, not going to have interval notation. The way we list this is you just list the values that you have. And this is only if it's points. If you have any lines connecting your graphs together or your points together, you will have set notation. You will have interval notation. But if you just have a bunch of dots on a number line, a bunch of dots on a graph, we call it roster notation technically, but it's a form of set notation. Okay, I know that's a lot of information. Do I have any questions before I move on? Okay, sweet. Let's move on. Part where it matters, domain and range. Domain, what is that variable? X. Domain is my X. We call these independent. Input. And if you are writing set notation specifically, you're going to write your set notation as X such that X is an element of all real numbers, comma, close your bracket. Whatever restriction follows every single time. So if you are asked, write the domain of this graph, and it's a question that says write it in set notation, you will start it this exact same way every single time. And I'll make a little note. Start set notation this way. Interval notation never requires that you include the variable, which is why we don't have like a space for like, how should you write interval notation? Range is going to be y, and that's going to be your dependent variable. Dependent. It's your output. And we start this. Biggest mistake I see when we get to answering questions about this. We get in the habit of using X. We use X all the time, and people forget that for the range, they should be using, Y. If you have no restrictions, you wouldn't necessarily have the comma, but if you do, you would have the comma and your restriction would follow. But same notation, different variable. I like to include that so that you have a place of reference of if I'm asked what to do for set notation, I know I need to start it this way. 9 times out of 10, you're going to be writing domain and range from a graph. So you have to know that domain is going to be your x-axis, range is going to be your y. The reason why I like to include a blank graph is so that I can kind of point this out to you. If you've completely, like, your brain has turned to mush over summer and you're like, what is the x-axis? What is the y-axis? We have our wonderful x-axis. We have y-axis. Just as reminders, you never know. And I also like to point out when we read domain from the left to the right. Domain L to R. Left-hand side, right-hand side. Same thing for the range. However, we read range from top to bottom. Range, top to bottom. A lot of people will confuse this and they'll read it backwards. So it's always left to right, top to bottom. And thinking of it like big picture in terms of interval notation, negative infinity is all the way down at the bottom of your graph. Positive infinity is always at the top. Negative infinity is at the left-hand side of your graph for domain. Positive infinity, right-hand side. So if I ever see a graph and the arrow is pointing off to the left-hand side, I know that that graph is going to negative infinity for the domain. So I like to point this out on a blank graph so that when we do this for graphs that you're given, it makes a little more sense. Do I have any questions about domain and range in general? Do we remember writing domain and range from Algebra 1? A little bit here or there. So taking inequality, just beefing it up a little bit for set. Let's go ahead and go to the back. We've got a graph. This graph is what you'll kind of learn a little bit later today is a parent function. This graph is a cubic parent function. It has a couple of different transformations on it, but it is a parent function similar to your quadratic. What I want to point out first is notice that we have arrows on the ends. Generally, we try when we make your practices and make your notes and all of that to include arrows. But if you ever notice that the graph is just like going off of the coordinate grid, but there's no arrow attached, most likely it's still an arrow. We try to draw them in, but if we forget. Now, looking at this alone, does it look like there's any restrictions on this graph? No. Is there any stopping points for this graph? So if there is no restrictions, and I'm going to make this note so that you can kind of carry it over, no restrictions on your graph, that means we are going to include all real numbers all the time. So all real numbers. And so by that, we're going to say for domain, remembering that domain is our x-axis, for set notation, I'm just going to say x such that x is an element of all real numbers. And if you're ever writing all real numbers in interval notation, every single time it's going to be negative infinity to positive infinity. So I know for this graph, no restrictions, all real numbers. If I had another graph that was facing the different direction, but it was 2 arrows going off and I had no restrictions, I would write the domain the exact same way. The only difference for range is we're going to change the variable to be y. Y. Negative infinity to positive infinity. So if you ever get a graph, and you will, you'll see different parent functions that don't have any restrictions at all. You write the domain and range the exact same way. So look back at your notes at this question and see like, oh yeah, we did a problem where there were no restrictions. How did I write the domain in that problem? You can copy it directly from what we have here because these two answers will be right every single time as long as it has no restrictions. Matthew, do you have a question or are you stretching? Stretching? Okay. Okay, no restrictions. Base idea of what a function is. Let's go in and let's look at number 2. Now, do I have restrictions here? Yes, because my graph, and by restrictions, I mean like, is there a stopping point somewhere on this graph? And we do. It looks like, and I'm going to start with domain, because domain is our x. If I'm reading my domain from the left side of my graph to the right side, the first value, the first place where I encounter the graph is here. It's a filled in circle. It's a filled in circle at -6. So that means when I start off my graph, and I'm going to kind of edit this a little bit. Bless you. Right here. This is kind of like my number line. -6. That's the starting point. Do I have a stopping point after that if I'm looking left to right? Do I ever have to stop again? No. And if you're not sure, I usually will say, take your pencil, put it on the line and trace. And if you ever have to pick it up or you ever have to stop, that would mean you have a restriction. And in this case, I don't have to do that. So that means it's going on forever. So when I write the inequality notation, I'm going to start off with set x. X is an element of all real numbers. My first value that's going to be there is going to be -6. And because it is a filled in circle, I'm going to include the equal to. So less than or equal to x. You can also, and just a little note here, or you can say x is greater than or equal to -6. Same thing. I don't care which direction you write it. I know some teachers in Algebra 1 taught you to write x first every single time. If that is the case, write x first every single time. As long as your direction for your inequality is facing the right way, we're going to give you credit. We, as your teachers, well, me, as your teacher, I look at every single thing that you do. We don't do multiple choice tests. We do open-ended tests. Every single answer and piece of work that you write down on your paper, I will look at. We give you partial credit. Every single piece that you do, every single addition and subtraction and division that you do to solve for x, we give you credit for. So we take the time to go through question by question so that, say for instance, you make a tiny, tiny mistake, you're not going to get the entire problem wrong. So we take that time because we don't want to punish you because you added instead of subtracted. So we will look at every single answer and see if it is right or wrong. Okay, for interval notation, I'm going from -6, positive infinity. I know I always have a parentheses in the middle because that's like my little 2. Infinities always have parentheses. What should the -6 have?
Bracket.
A bracket. Thank you, Scarlett. Bracket. If it was an open circle, we would have a parentheses, but because it was a closed circle, we're going to give it a bracket. Let's go in, let's talk set notation for range. Range is going to be my y values. Again, a lot of people in the many years I've taught this have said, well, how do I know there's a point there? How do I know that that's a part of the domain or a part of the range? If you see the line on the graph, if you see that there is a line there, we assume there is a point there. So when I'm reading my range from bottom to top, the first value that I'm kind of encountering is -4. And then I'm going up and going up and going up, and I have another stopping point. I have another stopping point when I get to that highest value for y, which looks like it's +4. So when I write the range out, the least value that it includes is -4, and the greatest value that it's going to include is +4, because that's the highest point I get. Now, if this graph, for some reason, had an arrow at the end, then I wouldn't have any restrictions on the top. It would go all the way up to positive infinity. But because there is a point there saying this is the highest value we're going to include, I have to stop there. So when I write the set notation, y such that y is an element of all real numbers, I can say I'm going from -4. Anytime you're going in between two values, the variable is always in the middle. So -4 less than or equal to y less than or equal to +4. Ooh, that's a bad one. I will not judge you for your curly brackets if you do not judge me for my curly brackets. Yes, Ite?
I didn't know which form goes first in the
Smallest to biggest. So the smallest will always be the first number that you write, unless you're flipping it. So another way you could kind of write this, I'm going to do another or. I can do it this way, but all of my inequalities would have to flip directions. Interval notation is always the smallest. Always will go first.
And is -4 in a bracket or parentheses?
Is it a filled in circle at -4? So if there's a line there, we say if there's a line there, it's equal to a filled in circle being there. So when I write my interval notation, it's going from -4 to +4, and we're both going to have brackets. Any questions thus far? Sweet. Okay, now where it gets a little funny, but not crazy, in the same realm of thinking, for the last one that we're going to do together. Domain and range. Domain is X, range is Y. There's a lot of little open spaces in here that we kind of have to cover. I, again, usually suggest kind of looking at what is the behavior of the graph. And if you need to draw like arrows and see like where am I starting, where am I ending, by all means. I'm not going to judge your paper if it's all written on the graph. As long as your answer is there and it's correct, that's what I care about. So let's go in and let's look at this. Domain first, I see that the first thing that I have left to right is a point at -8. That's kind of where this graph is starting. Anytime you run into an open circle, that is a stopping point. So I have an open circle at -5. So that's a stopping point. I'm going to have to stop there when I write whatever I'm writing in terms of set or interval. And then I keep going and keep going until I get to 3. So kind of connecting what I'm looking at visually. And then what else happens at x equals 3? I have this open circle that I was just referring to. What else is there? A closed circle. So I have two things. What do we think that closed circle does? And if you need a visual of what I'm kind of talking about. X, oops, highlighted the wrong one. 3. So on this value, x equals 3, there's an open circle and there's a closed circle. What do you think the closed circle does to the open circle? It turns it closed. It's kind of like it's filling it in. It's like we have a little dirt hole. We got a pile of dirt. The pile of dirt is going to fill it in. So what's going to happen when you have both of them is it's going to close it. Do we have to stop at closed circles? So if you're driving and you're driving down the road and there's a hole, but the hole is filled, can you still go over the hole? Yes, it's exactly the same idea. If you have both of them on the same value, skip over it. And then we keep going all the way to closed circle 7. The only time we have to stop at a closed circle is if it's the very end or the beginning. So when I write out this set notation, I'm really kind of just looking at going from -8 to -5 and then from -5 to 7. Those are the kind of two things I'm doing. So I'm going to do x such that x is an element of all real numbers. And then I'm going to have two things, unfortunately, for this one. We're going to say -8 less than or equal to x less than -5. That's going to take care of the first chunk. So that -8 to -5. And then we're going to have or, because we have to skip over, -5 less than x less than or equal to 7. My handwriting got smaller because I ran out of room. Let me make it a little bit bigger so you can see it. Now, again, this is kind of the turning point for most of my former students where they said, yeah, I'm going to do interval notation, because writing out 2 separate inequalities gets to be a little bit long. Whereas when we switch this to interval notation, we're going to go from -8, and that's going to be a bracket because there's a filled in circle, all the way up to -5 with a parentheses because that's an open circle. Pick up on the other side, -5 all the way to 7 with a bracket because that's closed. And we put a union in the middle. And usually here is where people are like, yeah, I'm going to do interval notation because it makes a little more sense. Otherwise, you're relying on the fact, did I write my inequalities correctly? And did I write both of them correctly? Before I move on, any questions for the domain? I know this was the more challenging one of the bunch. Okay, okay.
It's always like that.
For when you're writing it in between, yes. Okay, let's look at range. What is the lowest y value we're going to take on? -3. And it looks like, again, if you see a graph, there is a point. So -3, 1, 2, -3. There's a filled in circle. And then I go up all the way to, and I'm seeing that I have some open circles at y equals 1, but I also have a graph point at y equals 1. It does not matter if there's multiple holes. If you have one closed circle, that takes care of all of them. So at this point, I can skip over it. I don't have to stop at y equals 1. Where I do have to stop is at y equals 2, because that is the highest point it's going to reach. So when I write the set notation, y such that y is an element of all real numbers, I'm going to say it's going from -3 less than or equal to y less than or equal to 2. Interval notation, -3 to 2. And for this particular graph, it started with a filled in circle because the graph was there. Again, if you see a graph, that is equal to there being a filled in circle there. And it ended with a filled in circle, so we're going to have a bracket, bracket.